4. Mathematical reasoning. Mathematical reasoning refers to the ability of a person to analyze problem situations and construct logical arguments to create both conceptual foundations and connections to be able to process the available information and solve problems. It requires more than simply memorizing facts, but thinking beyond rules and procedures to form one's own questions and conjectures. People who can reason and think analytically tend to note patterns, structure, or regularities in both real-world situation and symbolic objects, as if those patterns are accidental or if they occur for a reason and conjecture and proof. So, literally, when we say mathematical reasoning ability, you have that deep understanding regarding a topic. You can easily recognize a pattern. Your higher order thinking skills are well developed. Those are the analyzing skill, synthesis, or creating, and evaluating or evaluation. Not just simply memorizing, but also analyzing. It's more on, if you have a critical mind, you have a mathematical reasoning ability, or a person has mathematical reasoning ability, if that person thinks analytically, critically, has a deep understanding regarding a topic, can compare things around them, combined, connect objects or things. That's the meaning of mathematical reasoning. Diagnostic learning checkpoint instruction. Classify the reasoning employed in the following arguments as inductive or deductive. When we say inductive, it means, I will write here below, inductive means specific to general. And then we say deductive, it comes from general to specific. So in number 1, the statement is, all numbers ending in 0 or 5 are divisible by 5. The number 35 ends with a 5, so it is divisible by 5. Our first statement, as you notice, is a standard rule. Nasabi daw dyan, lahat daw ng number na natatapos sa 0 or 5 madidivide sa 5. Then afterwards, nagbigay siya ng specific example, 35. Sa dami ng number na madidivide sa 5, 35 lang yung binigay niyang example. So it means, if you start with a rule followed by a specific example, rule to example, the answer will be deductive. So it is deductive. Number 2. The Gin Kings have lost their last 7 games. Thus, they will probably lose their next game. So, in number 2, ang first statement, sabi daw dito, yung Hinebra daw, natalo ng 7 sunod-sunod. So, 7 losing streaks. Tapos, sabi daw dito, ina-assume niya na matatalo ulit yung Hinebra sa susunod na game sa dami ng magkakasunod na talo. Okay? So, we have here our scenario, and you are predicting what will happen next. On the keyword is prediction. So, if you will predict what will happen next, that is inductive. Hindi pa nangyayari, nag-assume ka na, then you're using the future tense form of verb will, inductive. Number 3. To earn a master's degree, a student must have 32 credits. Team has 40 credits, so team will earn a master's degree. If you observe in number 3, it gives a general rule first or standard. A person should earn 32 credits to become a master's degree. Okay, so rule siya, general rule. And then, nagbigay ng specific example. Specific example, si team. Lagpas na nga siya sa 32 credits, naka-40 siya. So, team will earn a master's degree. So, rule to specific example, that is deductive. So, number 3, deductive. Fourth one, all dogs are mammals. All mammals have kidneys. Therefore, all dogs have kidneys. In number 4, if you notice, all our statements are stated generally. So, ginamit natin yung word na all. So, pag all, puro general statement. And then, in here, sabi, all mammals have kidneys. Ayan yung second statement. And then, nagbigay siya ng specific example ng mammals, dogs. And also, dogs have kidneys. So, general rule, general statement to specific example, deductive. Number 5, it says here, my daddy has curly hair, my brother has curly hair, therefore everyone I am related to has curly hair. It gives first a specific example. Yung tatay niya daw kulot, yung kapatid niyang lalaki, kulot, saka siya nag-generalize. Specific example to general conclusion, that is inductive. What methods can be used to construct effective mathematical reasoning? Number 1, inductive reasoning. It is the process of making general conclusion based on specific examples. So, ano mauuna dito? Siyempre, mauuna mo na yung specific example bago ka mag-general conclusion. Okay? That's why when we say inductive, specific to general. Examples, letter A. Every object that I release from my head falls to the ground. Therefore, the next object I release from my head will fall to the ground. So, in this example, nag-a-assume siya, nagbigay muna siya ng example, specific example, na lahat daw na binibitawan niya sa kamay niya nahuhulog sa ground. Saka siya nag-general conclusion or prediction. So, pinipredict niya yung next na mahuhulog sa kamay niya, mahuhulog din sa ground. So, pag nape-predict ka, inductive. Letter B. Every crow I have ever seen is black. Therefore, all crows are black. So, nag-specific examples mo na siya. Siguro, nasa window siya, then nakatingin sa bintana, nakikita niya mga 5 sigurong crow. Then, lahat yun kulay black. Then, afterwards, ina-assume niya lahat na ng crow black. So, inductive pa rin, specific to general. Then, letter C, based on available data, the Earth has revolved around the Sun following an elliptical path for millions of years. Therefore, the Earth will continue to revolve around the Sun in the same manner next year. Will continue, so predicting what will happen next, inductive. Deductive reasoning. Number 2. So, in deductive reasoning, it is the process of making specific conclusions based on general principles. Specific conclusions based from general principles. So, which comes first? So, nauna yung general principles bago ka nag-specific conclusion. Parang general statement or rule before you give specific examples. Letter A. All men are mortal. I am a man, therefore I am mortal. So, general statement, all men. Then, nagbigay siya ng specific example, sarili niya. Therefore, he is mortal. Deductive. Letter B. Given two supplementary angles with one of them measuring 120 degrees, the measure of the other angle is 60 degrees. So, general principle, we know the concept of supplementary angles. Supplementary angles are angles with sum of 180. Then, saka siya nagbigay ng specific examples. 120 degrees saka 60. So, 120 plus 60, the sum is 180. Sa dami ng pwedeng pag-add na angle na ang sum 180, isa lang binigay niya example. Isang pares lang. Letter C. If 6x is equal to 12, then x is equal to 2. 6x equals 12, general equation. Before you give specific example or value for x. So that's why it's deductive. Given these two arguments, argument 1, argument 2, which is inductive, which is deductive? Argument 1, the sum of two odd integers is an even number. M and n are odd integers. Therefore, mn plus n is even. So it means you give first a general rule before you give specific examples. Rule before specific examples, automatically this argument 1 is deductive. Argument 2. It says here, 3 plus 5 equals 8, 7 plus 11 equals 18, and 9 plus 21 equals 30. Then the sum of two odd integers is even. So as you notice, it's obvious, nagbigay mo na siya ng 3 examples. So examples before general rule, saka siya nagbigay ng general conclusion. Okay, o general rule. So automatically, argument number 2, inductive. Exercise. What rule of inference is used in each of the following arguments? Letter A. Anna is a human resource management major. Therefore, Anna is either a human resource management major or a computer application major. So we have different rules of inference, so you need to recall. First thing first, we need to translate this into symbol. Anna is a human resource management major, assuming this is your P. Then therefore, 3 dots symbol, and then Anna is either a human resource management major, so naulit lang siya. Again, this is your P. Or the symbol for or is like a V as in victory. A computer application major, another proposition, so Q. So the formula P, therefore P or Q is addition. So letter A, ang ginamit dito ay addition. Letter B. Ben is a game designer and a game developer. So when you represent in symbol, P, and Q. Therefore, Ben is a game designer. So naulit yung P. So anong formula to? So may formula tayo. If you have P and Q, therefore P nabawasan. So anong tawag doon? Simplification. Letter C. If it rains today, the college will be closed. So it rains is P. The college will be closed is Q. So meron tayong if P then Q. The college is not closed today. So nakita nyo, nag-negation. So this will be not Q. Therefore, it did not rain today. Then, ang naging conclusion niya, not P. So what formula is that? Modus tollens. So letter C, modus tollens. Letter D. It is rainy. If it is rainy, so this is your P, then the oval will be closed. So this is your Q. It is rainy, so naulit si P. Therefore, the oval is closed. Therefore, Q. So anong formula yon? Modus ponens. Then last, letter E. If I go swimming, so that's P, then I will stay in the sun too long. Then Q. If I stay in the sun too long, again, that's Q, then I will get burned. Q, then another new proposition, then R. If I go swimming, so this is your P, then I will get burned. R. So what formula is this? If P then Q, if Q then R, therefore if P then R. So alam na natin, HS, hypothetical syllogism, is the answer for letter E. Let us proceed to other terms in mathematical reasoning. Important terms. An argument constructed using the rules of inference is said to be valid. So all the rules of inference are valid because they were already proven. Let's proceed to tautology. Tautology, compound proposition that is always true. So as I said before, I taught you this, tautology, all the results are true. In the formula, P or not P. So given this example, it is raining or it is not raining. Contradiction. Compound proposition that is always false. Given this formula, P and not P. Example, it is not raining and it is raining. Okay? Contingency. It is neither a tautology nor a contradiction. So wala sa dalawa. So ano kaya? If P, then not P. So magulo. Example, if it is raining, then it's not raining. Confusing statement. That's why contingency. Then fallacies are incorrect reasoning which appear to follow the rules of inference but are based on contingencies rather than tautologies. So more likely invalid statement ito kasi contingencies. Tautologies are always true, so always valid. Examples. Global warming doesn't exist because the earth is not getting warmer. So mathematically invalid or fallacy. Okay? If silent movies are black and white and pandas are black and white, then pandas must be silent movies. Though it follows the rule of inference, but the statement is false. That's why it's fallacy. Then lastly, Romeo wears elegant clothes. Therefore, he looks handsome and wealthy. Okay, invalid. Fallacy.